Hi there. Today we're gonna go over with section 7.1, 7.2 graphs of exponential function. Okay. Uh, so at this time we have learned what's growth and decay, and we know what the smooth curve looks like of exponential function, whether it's growth or decay. Um, we have seen a little bit of the transformation, which we're gonna focus more on today's video. Okay. So again, this is a reteaching. All right, so y equals to the x is a growth. That's why the graph is going up there. If it's decay, it's going to go the other way around. Okay. For this one here, if there's a plus 3 additional term outside the x, it's going to go up by 3. Otherwise, so if let's say this is minus 3, this will go down by 3. If the value of the base there has a minus or a negative 2 to the x, this will reflect over the x-axis. And this one here, if there's an x minus 2, I know minus, we think it's go to the negative 2, but it goes to the right by 2. And down 1 means minus 1. So in other words, if this was a plus 2 here, this will go left 2. If this plus 1, it will go up by 1. Okay? Now, we did this example already in class. Let's do this example here. Identify the parent function of the problem here. So the parent function of y equals 1/2 to the x plus 5 is y is equal to 1/2 to the x. If we make a table here, since it's the parent function, it's easier to use -2, -1, 0, 1, and 2. We plug in -2 here, 1/2 to the -2. Since this is negative, so the 1/2, the 2 goes up. That will make this a positive 2. So it becomes 2 squared, or going to be 4. If the -1 plugs in there, so 1/2 to the -1. Since this one here is a -1, the 2 goes up. So 2 to the 1 becomes just 2. Any number raised to 0 except 0 will always be equal to 1. 1/2 to the 1 is 1/2. And 2 squared is 1/2. Squared will be 1/4 or 0.25. If we graph that one, it will give us -2. It will give us -2 to the 4th, -1, 2, 0, 1, 1 and 1/2, and 1/4. We have learned from the equation that whatever the additional term here represent our horizontal asymptote. Since that's plus 0 or invisible, we can say that the horizontal asymptote is the y equals 0 or the x-axis. This is our horizontal asymptote. And the graph will be something like this as the parent function of this problem. Have we answered the problem? Not yet. So the question here is, what is y is equal to 1/2 x plus 5. How do we graph that one? First, the plus 5 tells us to go up by 5. We can add 5 to all the y values, or we can move up, shift up the transformation to 5. All this orange point will go up by 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There you have it. And if you notice, the asymptote now is no longer y equals 0. It becomes y is equal to 5. And the graph will be like this one here now. So let's focus on the orange graph. What's the domain? The domain there is all real numbers. The range there, the range is from 5 going up, so 5 going to positive infinity. Transformation, t, shift up by 5 units. Next, what's the HA? The horizontal asymptote is already given y is equal to 5. There you have it. In case I ask you in the test, give me the complete table of that one. Just add 5 to this one here. So the answer will be 9, 7, 6, 5 and 1/2, 5 and 1/4. Done. Next. Let's skip that one. Let's do this one first. What's the parent function of this here? Y is equal to 3 to the x. Same thing, make a table. -2, -1, 0, 1, 2. You plug in the -2 there, 3 to the -2. Since 3 is in the numerator, and we would like to make the exponent to be positive, the 3 goes down, it becomes 1, 3, and then this is squared. What's 1/3 squared will give us 1/9. This will be 1/3, this will be 1, any number raised to 0 except 0 will always be equal to 1, and then this will be 3, and this will be 9. You plot the points. 1/9 is a very small number. So -1/9 is like this. -1, 1/3 a little bit higher. 0 to 1, 1, 3, and 2, 9. You connect them all. And that's a graph of y equals 3 to the x. But here, there's a -4, which is not additional term, but it's an expression together with the exponent. -4 means say we have to go right 4. Okay, for this one here, all the green points will go to the right by 4. So this one will go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and then the rest are just pattern. Was there a transformation going up or down? None. So therefore, there's no transformation that changed the horizontal asymptote. So answering this question here, that y is equal to 3 to the x minus 4, the domain here will still be all real numbers. The range here will still be the same as 0 goes to the infinity. The horizontal asymptote will be still y equals 0 because there's no movement up or down, which is pretty much the same thing as the parent function y equals 3 to the x. Get it? Next, let's go back here now. Now, what about this one here? There is a constant outside the 3. So y is equal to 2 to the x is still your parent function. So since we're doing the parent function, -2, -1, 0, 1, 2, you plug in the -2 there, will give us 1/4, 1/2, 1, 2, and 4. So we graph that one, it becomes -1/4, -1, 1/2, 1, 0, 1, 2, and 2, 4. We connect them. That's a graph of y equals 2 to the x. Although here, there's a constant 3. The meaning of that one, you multiply the y value by 3. That tells me that the answer will be 3 times 1/4 is 3/4. 3 times 1/2 is going to be what? 3 halves. 3 times 1 will be 3. 2 times 3 will be 6. 3 times 4 will be 12. So we plug the points, the -2 and 3/4, -2. 3/4 a little bit higher than that one. Let me use a pink one. -1, 3 halves. 3 halves is the same thing as 1.5. 0, 3, 0, 3, 2, 6, 2, 6. And from right there, no, I meant 1, 6, 1, 6, yeah. And then 2, 12, 2, 12, somewhere over here. How will you compare the orange point, the orange graph, and the purple graph? Their asymptote remain the same because there's no shift or there's no additional term here outside this term here, this function. But although the 3 makes the graph a little steeper, right? So the domain here will be the same, -infinity to +infinity. The range here will be from 0 to +infinity. The transformation is a scale factor of 3. And what else? The horizontal asymptote will be the same, y equals 0. All right? Hope you learned. Boom.